There are many things we take for granted each day: the air we breathe, clean water to drink, the sun, and thanks to the brilliant minds of Benjamin Franklin, Thomas Edison, and Nikola Tesla, electricity. Think about it. From lighting our homes and workspaces to keeping our food cold, from charging our gadgets to zipping around in electric cars, electricity is the unsung hero of modern civilization. All is great when the supply of electricity is secure and steady, but every now and then Mother Nature throws us a curveball just to remind us of who's boss, like the recent Snowmageddon event here in Texas that made national headlines. Although we continue to make significant strides in energy conservation and efficiency, with our cities getting bigger and population increasing, our demand for energy just keeps growing. Enter the smart grid. Picture more efficient transmission, quicker restoration of electricity after power disturbances, reduced operation and management costs for utilities, and even cheaper bills for all of us. And let's not forget about its green energy upside. It's like the ultimate win-win-win situation. Happier utilities, happier consumers, and happier planet. I'm your host, Raymond Yin, and with me today on the Tech Between Us to discuss the smart grid, where it stands today, and what to expect in the future is Chris Irwin, Program Manager at the Office of Electricity within the U.S. Department of Energy. Chris, welcome to the podcast. We're excited to hear your thoughts about the smart grid.
Thanks a lot, Raymond. Nice to be here.
So, Chris, can you briefly tell us a little about your many roles as it relates to the nationwide initiatives from Smart Grid?
Yes, I joined the Department of Energy just about 15 years ago at the beginning of a really enormous investment in American electric infrastructure called the Recovery Act. And so within that, we had about $7 to $8 billion to improve American electric infrastructure. And so I was brought in to help participate in those grant programs. Shortly after joining the Department of Energy, I became responsible for about $1.6 billion in grants for the federal government to make smart grid investments. And so ever since then, I've worked to sort of guide external parties on grid modernization and then, of course, pursue research on the grid, especially when it comes into the distribution grid, your neighborhood grids and things like that, and keeping up with all of the renewable energy and electric vehicle habits that we're adopting over time.
Sounds like you're bringing a lot of people to the table through the grant process and through all the different programs that you're running.
The grant process, of course, was wonderful for the recipients because they got a discount, courtesy of the American taxpayers, on the modernizations that they needed. But it also gave me a tremendous education really around the country on how to do modernization in a small, under-resourced utility out in rural areas, how to do it in a major metropolitan area like CenterPoint Energy in Houston.
Literally from soup to nuts.
Yes, sir.
It feels like the word smart has been really overused by marketing departments from everywhere. How exactly would you define the smart grid?
So broadly stated, there have been a lot of analog devices in the grid. Is those attractive gray trash can-shaped transformers at the tops of the poles are they're analog devices. They don't really have a lot of digital guts to them.
Okay.
So broadly, smart grid is adding digital sensors, digital controls, and communications capabilities to all of these assets. But I think it's actually more helpful for folks to understand smart grid in terms of what we're pursuing. We want to make sure that consumers have access to the information that they need to live their lives and to interact, if they choose to, with the grid. We want to make sure that our systems can heal themselves when trees fall on the line, as they tend to do from time to time. Smart grid technology allows us to reroute power around those problems automatically. So it really improves sort of the resilience and the reliability and the customer focus of the electric grid.
We have often heard in the news, in various reports, really about the need to upgrade the grid and the infrastructure, which is obviously right in the middle of where you operate. And what changes do you feel are really driving that need to move from, like you said, the analog grid to the digital grid?
Well, certainly just our appetite for electricity is increasing, but also our lives increasingly depend on the continuous flow of electricity.
Mhm.
Back in the olden days, where cash registers and everything else didn't rely on electricity, it didn't matter if the lights went out, you were good to go. But now society pretty much comes to a standstill when the electricity stops flowing.
Right.
And so we need a way to affordably pursue new levels of reliability, new levels of power quality. But I think, the big forces at work today on our grid have to do with decarbonization and electrification. Those are the really big themes that are driving the need for modernization today.
And we've heard those themes over and over again in the various episodes of the podcast, sustainability, and like you mentioned before, reliability and resilience. And speaking of resilience, I think we've all got a pretty good idea of, or at least, in our heads, a definition of what we think reliable is. So, what does resilience in the modern grid look like?
Reliability means the lights stay on all the time. Are we keeping the lights on during the blue sky times and things like that? But when the clouds go gray or when the snow starts to fall, that's when resilience becomes the more important question. When things do go wrong, can you recover from them? How quickly can you recover from them?
Mhm.
And there's a lot of different techniques to obtain that,
Okay.
and we kind of need to pursue all of them when we're looking at the electric system.
Based on kind of what you've said, reliability is making sure that under normal circumstances, everything works the way it should. We go in, turn on the lights, the refrigerator keeps the food cold. But resilience is when things don't go so well, as having lived through what we call the snowmageddon of February 2021. Things didn't go well, and things, like you said, were not resilient. And, we had an unfortunate situation here in Texas.
Absolutely. And like I said, there's more than one way to pursue it. If
Mhm.
you look at resilience in the form of a data center, which are entirely dependent, their lives depend on electricity, is that they're set up for independent dual feeds from the transmission system. So two separate lines coming into their facilities is what they prefer to see.
Okay.
And then, of course, they've got a stack of diesel generators across the back of those facilities. And so they have their resilience plan. It's two connections to the grid
Mhm.
and one survival connection to the diesel gen sets that they maintain. So that's sort of a good way to think about how could we make that resilience occur at the neighborhood level, at the customer level.
Right. Yeah. And on a citywide level rather than on an individual building level. Here at Mauser, we've got banks of generators. When the power flickers every once in a while, well, we're in good shape. The warehouse keeps moving.
Some of the things that we need to think about on the grid is we are there for societal resilience. We're there to raise the resilience quotient for everybody.
Mhm.
And then you get to allow those individual organizations and people to choose their own resilience level. They can dial it up a notch with their own generation or their own storage or their own solar panels.
You're with the Department of Energy. What other groups are involved in establishing the new smart grid and these new frameworks?
If we just stay on the government side for a moment, the Department of Energy has the research and the science mission around
Mhm.
energy writ large, and the Office of Electricity is kind of the guardian of the grid. How can we make it better? How can we keep it affordable and things like that?
Okay.
But the electric system isn't something that's just researched. It is built and maintained, and that is almost exclusively by the private sector, by your very own utilities, but also regional transmission operators that are not government entities and things like that.
Mhm.
But one also needs to have some oversight, just like all aspects of society have some kind of regulatory oversight as well as their own self-policing manners. And so FERC, the Federal Energy Regulatory Commission,
Mhm.
looks at the bulk power system, all the big transmission towers across the United States and the generators, and they oversee the healthy functioning of the markets and the systems that make our reliable grid today.
So you guys at the Department of Energy are the research arm looking into new components, new systems, new ways of doing things, and then passing that knowledge over to the individual power companies and distributors across the nation.
Yeah. And one thing I wanted to add,
Uh-huh.
two additional neighbors. The Department of Agriculture is a partner
Oh.
in the grid modernization
Mhm.
effort. They operate the Rural Utilities Service. And they provide grants and they provide loan instruments and support for rural electrification. They were the folks who got rural electrification going across the country when it didn't make any economic sense for a utility to expand there. And they have that role today. And so the rural utility service continues to be provided right out of agriculture. And then the Department of Transportation, because with transport electrification, they have a vested interest in understanding the interactions between the grid and electric vehicles to make sure that they can discharge their transportation mission with this new understanding of the electricity system. And so we actually have a joint office with them looking at transportation and energy.
Going back to your former thought of one of the driving forces of the smart grid being electrification. So as cars become more electrified, as like you mentioned, everything else in our lives becomes more electrified, more and more of these partners are coming in and working in their areas of expertise, working with you guys in the Department of Energy to make sure that the grid keeps expanding and stays reliable and resilient.
If we're looking to expand to handle all of the electrification needs, which is electrification of transportation, all of the building loads, all home loads, is move it away from, say, the traditional fuel oil approach to electric supplied heating and things like that. So that represents potentially doubling the amount of energy produced and distributed by the grid. And so one way to go about that is double the amount of generation that's out there up at the top end of the system, double all the poles and wires, and we're good to go. But it's a wildly unaffordable and inefficient path to the future. And so as we bring these new partners in, as we intensify our electrical relationships with homes and buildings, we need to figure out how to cooperate with them, because that's what reduces the cost of infrastructure as it becomes really sort of a more democratized energy system where we can accept help and participation from smaller and smaller resources.
So what you're talking about is kind of the solar panels on someone's house actually contributing to the grid when the demand is low at the house, and even that on a larger scale.
And so, of course, solar panels and net metering is usually the process in which their contributions to the grid are recognized so that they can save money on their bills and things like that. That has been around for decades. But as we succeed at that revolution, is we need a way to control the flow of electricity across these millions and millions of resources. We already modulate the flow of energy from the very large generators. We tell them when and where to operate so that we have this reliability. We don't have that advanced coordination that can go from 1,000 units of coordination to 10 million units of coordination. And so that's where the digitization of the grid becomes really critical.
That's interesting because, like you mentioned, I never really thought about, I can see my house contributing whatever to the grid, but I never really thought about the aggregation of all that really becoming a major part of the overall system, enough to almost replace fossil fuels or be a significant portion of the overall power generated.
And I think that's really important for us to understand, is that we could potentially solve our energy needs with a generation-only thing, but if we can actually coordinate our behavior with the energy usage on the edge of the grid, is that we can make our system dramatically more efficient. And so that's the real opportunity, is to rely on what customers buy for their own happiness. So they may want a solar panel just because they want to have that green energy produced locally at their home, and their ability to share it with the grid is sort of a side benefit. And with inverters, they're incredibly powerful, adaptable, and controllable devices, and they're generally what's in front of all of the cool resources these days.
Definitely all the new resources, whereas I think fossil fuel generation is more to the traditional grid.
Correct. And that does bring an interesting point, is that if you hang out with grid nerds long enough, you'll hear about the loss of inertia in the system. And that has to do with every thermal power plant in the United States has a big rotating turbine, a big mass of steel and iron that's rotating at a very healthy clip. And so when there are variations on the grid, you have thousands of tons of mass that drive it right back to that 60 hertz signal. And so as those coal-fired power plants get retired and things like that, we're losing this inertia in the system. Solar panels don't have inertia, but they do have inverters. And inverters can shape the power coming out of them in ways that are identical to inertia. They can provide that firming track back to 60 hertz if they have the right information.
It sounds like as we move into these new energy sources, the inverter-based networks, control and communication are going to be much, much more important than they are currently today. Can you talk a little bit about more the communication side? How will they have to communicate to be an effective mass source of production?
So one thing I want to start on before I answer your question is the fact that we can control coal, natural gas, nuclear, solar power plants up on the big grid today. We say jump and they say how high because we have control over them and things like that.
Right.
Customer-owned resources are customer-owned resources. And so there is respect and recognition that we're asking for something. We do sort of simplify and we talk about control, but there actually has to be some respect for the customer and that we figure out ways to ask nicely and receive high-quality grid services in return. And so with that caveat that's sort of important for us at the Office of Electricity is we can move to the communications because, of course, so much connectivity in our society today. And it used to be that the grid had to pay for connectivity to everything that it talked to. And so if you bring a smart meter onto the side of someone's house, you've got to bring the communications and things like that. But now everything has connectivity with it, quote unquote, for free, just in the purchase price. And so we can really take advantage of the connectivity of these assets, both the connectivity within the grid, on our side of the grid, and then the connectivity, what we say, behind the meter.
So really it is connectivity, whether it be a wide area, local area, it's really becoming ubiquitous. You're just taking advantage of what's already there and what's already present within the new network.
Absolutely. And so as new communications technologies come online, we evaluate them. We do have our standards for quality and uptime and things like that. So it's not just a throughput game. But as the grid becomes smarter, it has a communications payload and backhaul requirements that are associated with that.
Thanks for joining us for part 1 of our conversation with Chris Irwin. Don't miss our next episode as we dive deeper into the smart grid. If you'd like to learn more about this technology, the Tech Between Us podcast is just one piece of Mouser's in-depth look at this subject. Explore the entire Empowering Innovation Together content series at mouser.com/empowering-innovation for technical articles, use cases, and more.